Hi, this is Garrett Gonzalez, and this is part two of the development of skin and skin derivatives. So I mainly have skin derivatives, um, and Joshua just gave a presentation on mainly skin. So I'd like to start off with hair. Um, so biggest thing with hair is that when you're still developing, the first hair follicles, not the actual hair, but the follicles within, um, are going to be developed around the second month. So all of this comes from the neural crest cells um, and also the ectoderm. So the rest of the fetus will develop follicles during the fourth month, and they stop around the fifth month. So we have about 5 million follicles. The follicles are like the hair beds, and we won't have any more follicles after that. Um, anyway, so a hair germ is the collection of the epidermal cells, and so here at the dermal condensate, that's what that is talking about. And then they start to invaginate and to grow deeper and deeper, and then so right there, the it is signaled by the dermis. So down here, this is the epidermis up here, and then the dermis here. So there's signaling that calls the condensate down, and it brings it into the shaft-like structure here. I don't know if you can see my mouse or not, but going down the shaft, and it will burrow itself and then become the dermal papilla, or the mesenchyme are the mesodermal cells as well. So right here, you can see the formation of the erector pili muscle, which is what gives you goosebumps. So the erector pili muscles, you don't have any in your eyelashes or in your eyebrows, which is pretty interesting, but everywhere else you have goosebumps. So um, how do I, next slide, okay. All right, so there's a certain hair cycle. So the anagen phase is all about cell growth, is about hair growth from the follicle. Catagen phase is released. Oh, so when it's released from the follicle, it begins more growth. So right here, we are done with the growth, and then the telogen phase is all about the hair is just staying. It's not growing. It's not doing anything. It's just normal hair. I think it was about 10 to 15% of all hairs are in the telogen stage. And then the anagen restart is all about the hair releasing, and that's called the exogen. And so that's when you shed hairs. Like I lose an eyelash a day, which is pretty crazy. I feel like it's an eyelash a day at least. So the pigment is established by the surrounding melanocytes. So that is back on right here. So the melanocytes are, I believe they're like around here. This diagram doesn't give that good of a picture of it, but the melanocytes are right next to the hair bud of the root. And so there is a keratin layer of all the hair. So it surrounds the hair as it grows. And so within the womb, the hair that emerges is from the follicles is around 12 weeks, and it's not colored, and it's pretty thin. So after the infant's born, there's two kinds of hairs. There's vellus and there's terminal. But before there's vellus and terminal, those hairs they are called, I believe it's a lanugo, and the vellus hairs are basically puberty hairs. They're shallow, not colored. What I mean by shallow is the roots. So the root of the hair is not very shallow, or is very shallow. And so when we have sexual hormones that like estrogen and testosterone that help pigment and deepen these hair follicles and hairs and become darker. So that's why, when guys are growing up, they have a random dark chest hair instead of this peach fuzz, and you're like, whoa, what's going on? So next up is the glands. So this is a mammary gland. This is actually the tip of the nipple, and then around it is the alveola. This is a sweat gland. This is a sebaceous gland right here. And then we have, this is the apocrine gland. Um, and so we're going to be going over 4 kinds of glands. These glands are fairly similar, but the mammary gland is a little different, and that's what we're gonna talk about those differences here in a second. So the sebaceous glands, these glands lubricate. So if you ever feel your hair is getting oily throughout the day and you need to wash, it's because of the sebaceous glands. So that is hooked up right here. It's in the formation of the hair follicle itself, and it will bud right here. And so it sends those oils there. So it's called sebum. And after about 4 weeks, it begins to form around the hair. So some parts of the genitals, we won't get into details, but they also have the sebaceous glands, even though there's no hair on those surfaces. So it's very important that you have those oily surfaces within your skin, especially for those for specific purposes for procreation. So a holocrine mechanism is used to release the oil. So the holocrine mechanism is basically these vesicles are formed, and they have the oil within them, and then they're broken. These vesicles are broken down, and the oil is released. So the sebum, there's tons of it. It's actually used as a waterproof barrier for the fetus, and it mixes up with a few other things, and it helps form that barrier. Um, but after birth, you don't really see a lot of sebum until puberty, and then it helps the skin stay hydrated. So obviously, it's gonna be a big contributor to acne. So you gotta kind of get it under control. So the apocrine cells, or apocrine glands, sorry, form also attaching to the hair shaft, and so it is long and very coiled at the end. There's no bends. This is actually the same structure as the sweat gland, except this gland is associated with the hair follicle. Now, the sweat gland is not associated with the hair follicle. It can be found anywhere. So the apocrine mechanism is used to secrete the vesicles, and so it's just these vesicles that are released and then later are broken down as well. So they're scattered all over the body, but they're not in high concentrations, and they're found mainly on genital areas for both males and females. So they're scattered, they're not very concentrated. So that's apocrine. Sweat glands, as we were talking about before, they burrow down, highly coiled here. They form, and they're burrowing cells down into the dermis, and then the massive cells hollow out. So that's pretty interesting because the outer cells like thin out, and then the outer cells are called the myoepithelial cells, and so they're actually connected to the sympathetic nervous system. And as you are running or you're nervous, you start to sweat, and so the release of sweat is by the myoepithelial cells, but the secretory cells actually secrete the sweat through the glands and through the tubes of the gland, and so it'll come up, and then you'll excrete sweat. So pretty interesting. So the reason why the glands, the mammary glands, are different is because most of these glands start with just a little bud, but then the buds start to, so you call that the primary bud, but these are secondary buds that are forming, and so they get bigger and bigger until there's about, I think, 15 to 25 of them, and then they start to hollow out, and that is where we get our lactate. So we have about development of these glands and the ridges. So typically you have these ridges along your chest of the developing embryo, and the ridges start to disappear until around the chest area, and that is where the mammary glands actually start to bud, and then that's where the secondary comes, and then they hollow out. So right here, this is where the mesodermal cells will actually, and if you can't see my mouse, it's the very last picture F. You see this little purple tube at the bottom. It's like, it's an inverted nipple kind of. So those are the mesodermal cells proliferating, and then the top of it is actually the nipple itself, and then around it is the areola, and the cells start to divide, and that is what is called the nipple itself. So pretty cool. That's why mammary glands are a little bit different. So and they're also very important for the immune system and for nutrition of the infant. So skin grafting research, I didn't want to include a picture because the skin grafts were pretty gnarly, but there's some research being conducted on the signaling pathways as far as how the sweat glands develop. And so they're trying to make the skin as normal as possible. And so they've been developing ways to get the sweat glands to be present after the skin has like in the development of the skin graft, which is pretty interesting. Anyway, I think it would be super cool for them to get not only sweat glands but all other glands as well to have that as normal as possible. So pretty cool. So teeth, that's the most important thing. So there's a lot about teeth right now. And so I'm going to try to break it down as much as I can because we're running out of time. So during the 6 week of development, we have, you ever see a grandma with no teeth? She takes out her dentures and she has just these gum pieces on top and bottom, and you're like, holy cow, she's got no teeth. So that's kind of what you start to have. So these U-shaped dentureless ridges, and so 10 buds, kind of like those gland buds, begin to form, and they start to deepen. And so as you can see, so these are derived from the neural crest. These are mesodermal cells, and they will be developing into the dental papilla. So at first, we will have the cap stage. So here's the bud, and then the cap will start to invaginate. That's the dental papilla right there. And then it will invaginate so much and form our bell stage. So nearest to this bell differentiate, these cells right here along this ridge will begin to form odontoblasts, and that is all for the purpose of dentin, which if you're not familiar with what dentin is, you have your enamel, which is the top of your tooth, and then the dentin is right below it. So pretty cool. So your odontoblast will first, of course, release predentin. So predentin is this little pink stuff. So you're going to have right here these odontoblasts, these little dots in picture D, and then the pink portion is going to be the dentin forming. So it's either going to be predentin and then forming to dentin. It's growing from a bottom to top kind of formation. So then there's 3 layers of the enamel epithelium. So there's the enamel endoplasm, I believe it is. It's the middle layer, and then there's also 2 epitheliums, the outer and the inner, that kind of give the space for the enamel to form. So the dental papilla eventually forms the pulp of the tooth and helps with the root and circulatory system of it for the blood. And then the dentin finishes formations. The amoeboblasts will be triggered by the odontoblasts, which forms the specific enamel, and the enamel will just keep growing up. And so it's pretty cool how that kind of emerges. So at the end, the dentin is your root, pretty much. So it needs to be covered by protection. So cementoblasts will come in with cementum and cover it. And so that'll help your root surface not be exposed and help protect the tooth as much as possible. So these are some of the, I'm sorry it's kind of boring, but these are kind of some of the signaling pathways that we learned in the very first chapter we read. These are some of the signals that are used, like sonic hedgehog right here and Wnt signaling. These are different phases of the tooth. I would explain it more, but I'm running out of time. But it's pretty cool how the different kinds of signaling will help with different portions of the embryological formation of the tooth. So pretty fascinating stuff. So our permanent teeth, I don't know where, oh, there it is. So with our permanent teeth, we have our bell-shaped curve right here, and it's actually starting to form the enamel space there. So this portion right here off to the side, it looks like a mini bud. So that is the second or the secondary bud, and so it actually stops in the secondary or sorry, the bell stage, while the primary is forming. So your primary tooth is your baby tooth, pretty much, and then you have your permanent tooth right here. So you don't have this massive permanent tooth behind it already. It stops in this stage while this is developing, and then these start to erupt. Your little kid ones start to erupt around 18 months to 2 years, and then you start getting all your baby teeth in, and then you have these secondary bulbs that around 6 to 8 years old. It depends on some people. It takes until they're 13 to get all of their um, baby teeth gone. But it's interesting because these actually kick out the bulb. Um, they kick out the root, so they eat away at the root as they continue to grow that enamel, just like the primary tooth does, and that's why you ever feel the wiggle when you were a little kid. It's because the root's gone. It's the secondary tooth that's actually eating away at it. And the interesting thing is, um, the ones that don't have primary teeth, they actually have this bulb anyway, and it just burrows deep into the jaw. So I wanted to show this picture because you can see in the back jaw portion, the molar, there's no tooth before it, which is pretty cool because there's still those little buds were in there, and so they come up anyway, but around 6 to 8 years old, then you'll have your adult molars. Um, and then you can see here, this is how the adult teeth are coming in and actually eating away at the root of the baby teeth. So pretty cool representation with this picture. Um, so current research being done on teeth is, how sharks actually grow in their teeth. They lose teeth all the time, and they actually have several rows of teeth. It's pretty crazy. So humans do a similar thing, but they only have one bud to replace, and so that's when we become adults. But the problem is that sometimes we don't take care of our teeth, or sometimes we have, malformations of the mouth when we're growing up, and we actually lose teeth or aren't born with teeth. So they've been researching on how to develop a good enough replacement, by being able to kind of adapt to what the sharks are doing. And so we don't lose teeth as easy as them, but we also don't, eat huge seals or surfers. So that's another that's another thing. We just eat steak. So, but it's just a really cool part that they're doing research on that, so that they can develop really good replacements instead of just implants. Or it can really change a lot of things as far as development. If you had children have these secondary buds that they didn't have, and it could be able to change a lot of things. So it's pretty cool and pretty fascinating stuff. So thanks for listening to the presentation. I expect at least 100 views on this video, and hope you guys have a good day.